Okay, let's jump right into this explainer because we are about to completely flip how we view AI. If you've been looking at artificial intelligence as, just a handy digital assistant or a clever chatbot to write emails, we're going to fundamentally reframe that perspective today. We're diving into a fascinating energetic paradigm, or EP, research brief. And its core argument? OpenAI isn't just building neat software tools anymore. They are rapidly evolving into a massive, physical, industrial infrastructure provider for intelligence.
Here's our roadmap for the breakdown today. We'll start with from answering to acting, move into the intelligence factory, look at the execution layer, explore the new operating system, tackle the infrastructure paradox, and wrap up with governing the AI grid. Let's get to it.
Starting with Section 1, from answering to acting.
To really grasp this shift, we've got to break the chatbot illusion first. The most critical evolution happening right now isn't that AI is just getting better at answering our questions fluently. It's that these systems are moving from just generating responses to actually executing tasks in the real world. Think about it. A standard response model basically just sits there, waits for your prompt, and spits text back. But an agentic task execution system, that is totally different. It reads context, plans out multiple steps, calls on external tools, modifies files, and actually monitors feedback. This execution system is literally becoming an entirely new labor substrate that actively operates software and triggers real transactions long after you've closed your laptop. And that brings us to the core thesis of our source material, which is honestly profound. The deeper movement we're witnessing here is the conversion of intelligence into an actual industrial infrastructure system. We're talking about a system that produces reasoning, writes complex software, generates research hypotheses, and drives organizational decisions at a massive scale. It's becoming a fundamental utility, completely governed by heavy flows of energy, computation, and authority.
Moving on to Section 2, the intelligence factory.
So let's look at the physical reality of this shift. The paper calls this the token factory model. And guys, this isn't just software magic happening out of nowhere. There is a very specific causal chain here. Physical energy, like literal electricity and raw materials, turns into compute. That compute then becomes tokens. Those tokens are converted into reasoning paths. That reasoning leads to real-world agentic action. And finally, that action results in massive scientific, economic, and institutional change. Every single step in that chain creates immense value, sure, but it also introduces critical bottlenecks and risks.
Frontier AI doesn't just float around weightlessly in some invisible cloud. The AI stack is, at its absolute base, a massive physical energy conversion system. To put it in perspective, a single AI query can use nearly 10 times the electricity of a standard Google search. It requires real land, huge amounts of power, massive volumes of water for cooling, and highly advanced chips just to produce its cognitive output. So if any physical layer runs out of resources or fails, the whole intelligence stack loses its stability.
All right, Section 3, the execution layer. As we travel further up this industrial pipeline, we hit the execution layer. This is where those raw tokens are converted into highly valuable, specialized labor. If we look at software development, things like codecs and coding agents are evolving way past simple productivity tools. They're becoming a true execution layer. A software agent today can work in parallel, review massive repositories, explore alternative code structures, and operate inside cloud sandboxes. But because it acts as actual software labor rather than just a helpful assistant, you absolutely need strict permission architectures, rigorous testing, and tight controls so it doesn't quietly introduce vulnerabilities into your codebase.
And it definitely doesn't stop at coding. Think about your own daily workflows. Honestly, how much of your white-collar work is really just acting as the glue between unaligned software? Copying data from an email, pasting it into a tracker, summarizing a meeting for a database, you know the drill. Enterprise AI is explicitly designed to completely eliminate that human glue work across calendars, documents, messages, and databases.
But, as the source highlights, this creates a really tricky enterprise trade-off. For these agents to actually be useful in your organization, they need deep internal access. They need high context. The paradox here is that high context immediately shoots your risk surface through the roof. It creates a massive permission bottleneck. The more the AI knows about your business to improve efficiency, the more damage it could potentially cause if its permissions, reasoning, or guardrails are flawed.
Now, if we move from the office to the laboratory, scientific discovery is really the absolute highest value frontier for this execution layer. Out there, AI shifts from being a basic research assistant to a true research partner. It's not just summarizing papers anymore.
It identifies causal bottlenecks, generates new biological candidates, ranks the value of evidence, and actually designs experiments to narrow down vast, incredibly expensive search spaces. It actively guides physical validation in the lab, which could totally revolutionize the speed of medical and material breakthroughs.
Next up, Section 4, the new operating system.
Because AI can now execute these incredibly complex scientific and enterprise workflows, the very operating system of how we interact with computers has to change. We're rapidly shifting away from human-native interfaces. The whole era of clicking through screens, pages, and apps, that's making way for an action-first, agent-native operating system. In this task-based computing paradigm, you just state a goal, like book the trip or reconcile the invoice, and the system handles all the tool calling and routing in the background. It is direct, goal-oriented execution.
This new operating system is a real game changer because it dramatically lowers the barrier for domain experts to build software products. If you understand a specific operational pain point, AI essentially gives you that first execution layer to build a solution without needing to hire a massive engineering team. But our source makes a brilliant point here. This simultaneously relocates competitive moats. If anyone can execute the technical side, defensibility completely shifts away from code and moves into structural advantages, things like proprietary data, institutional trust, distribution networks, regulatory access, and deep workflow ownership.
Which brings us to Section 5, the infrastructure paradox.
As we scale up these intelligence factories, we run straight into this massive tension that the paper calls the infrastructure paradox. We kind of live under this illusion of democratized AI right now, mostly because millions of people have broad access to use these tools. But here's the reality check. Being able to use a system is absolutely not the same as controlling it. The reality of this new era is highly concentrated control. A tiny handful of organizations actually own the underlying toll booths, the compute, the interfaces, the safety boundaries, the models, and the pricing.
And if this delicate energy conversion system loses stability, the research warns us about 5 major failure modes. We could see a massive compute overbuild where infrastructure debt just spirals out of control. We might hit a low-margin utility trap. There's governance lag, meaning agents get deployed way before we have the rules to manage them. We could suffer from scientific overconfidence, where labs are flooded with plausible but completely false hypotheses. And finally, extreme power centralization, which creates severe geopolitical and institutional risks.
Finally, Section 6, governing the AI grid. To prevent those failures and build a real framework for safety, we have to recognize that every single layer of this stack requires very specific accountable control boundaries. This energetic paradigm architecture table is an absolute goldmine. It perfectly illustrates how everything is connected, from the physical infrastructure of raw electricity, straight through the model layer, inference, agent workflows, all the way up to scientific discovery and economic governance. Every single layer converts energy into capability, and every layer must answer specific control questions to prevent systemic instability.
A governable intelligence infrastructure basically demands deliberate architectural design. Just making the models bigger isn't going to cut it anymore. The system requires strict scientific validation discipline. It needs highly controlled agent permission architectures with reversible actions. We need detailed enterprise workflow maps, deep compute economics discipline, and, above all, public legitimacy. Because if this system is allowed to operate blindly, the consequences could be catastrophic.
I want to leave you with a massive strategic question drawn right from the conclusion of our source material. As intelligence becomes the new electricity, we have to ask, who will actually control these new intelligence factories? How will their outputs be governed? And most importantly, can society really achieve broad, democratized access to these capabilities without surrendering the very operating system of our work, our science, and our institutions to a centralized few? It is a fascinating paradigm shift, and the decisions being made right now about this infrastructure will absolutely shape our reality for decades to come.